Okay, today's lesson is on 5.5, solving polynomials by factoring. Uh, we're only going to do factoring, and actually I'm going to break this one up into 3 different factoring parts, video on each one. But the main factoring ideas that we're going to talk about today are types of factoring, which are going to include greatest common factor, which we did back when we did quadratics. Number 2 is sum and differences of 2 cubes. That's what today's video, this video is going to be on. Factoring by grouping, and then quadratic form. Okay, so just a real quick review of factoring with greatest common factor. If we have a polynomial that has a greatest common factor, we factor it out basically using the distributive property but backwards. So for example, if I've got 125 x to the fourth minus 50 x to the second. Okay, this is just a quick example. I look for greatest common factor. Okay, so 25 goes into both 125 and 50. X squared goes into both as well. When I factor out 25x to the second, I basically am dividing each of these by that. So I end up with 5x squared minus 2. Now, as long as I multiply this back, I should get what I started with. Okay, that's greatest common factor. Factoring trinomials. Okay, well, that's another thing that we need to remember how to do. X squared plus 9x plus 20. Okay, that's a trinomial, 3-term polynomial. I should be able to factor this if it's factorable, of course, and I look and see. If I put x here, they should multiply to be x squared. The first terms have to multiply to be the first term. The last term, we need these 2 things to multiply to be the last term. The middle adds up to 9, so if I put a 4 here and a plus 5 here, it looks like that should work. I test it again, always test them by foiling it back together. X times x is x squared. 4x plus 5x is 9x. 4 times 5 is 20. Differences of squares. That's something that we're going to use a lot today. So we need to remember how to use difference of 2 squares. If I have x squared minus 25, that is a difference of 2 squares. So where when I factor this, the square root of x squared goes here and here, so x times x. The factors of negative 25 would be negative 5 and plus 5. This works because when you add up the middles, they add up to 0. Now, one thing I want to talk about real quick is the sum of 2 squares. Now, we've never really factored that, and that's because we can't. The sum of 2 squares, like x squared plus 4, is not factorable. Okay, it's not factorable because you can't multiply something to get 4 and add up to be 0. Okay, so just remember that. You cannot factor a sum of 2 squares. Now, today, like I said, the lesson's going to be on sums and differences of 2 cubes. We can factor the sum of 2 cubes, even though we can't factor the sum of 2 squares. So we're going to talk about that. Okay, so that's this portion of the video will be on that. Okay, let's see, this is the sum of 2 cubes. Basically what we have here is we have 2 perfect cubes added together. That is factorable. It is factorable. It has a pattern to it. You need to know the pattern. And the pattern to this, factoring a sum of 2 cubes, is this. Well, first of all, we need to know what is being cubed. A is being cubed here. B is being cubed here. Okay? Long as you know what A is and what B is, what's inside the cube, you know what to put in your first factor. The first factor is just A plus B. Okay, so whatever's being cubed here goes here. Whatever's being cubed here goes here. Then you take a and you square it. That's your first term of the second factor. The middle term is minus ab. So it's whatever a is and whatever b is multiplied, and it becomes a minus, and then the last term is plus b squared. So it's a squared minus ab plus b squared. Okay, that's the pattern. Let's talk about that. Let's do that on this one right here. What's being cubed? Well, x is being cubed. What's being cubed here? Well, in that case, 4 is being cubed. So x is like my a up here, 4 is like my b. So when I factor this, my first factor is just x plus 4. I always use the same sign in the first factor, okay? So since it's a plus, we use a plus. Okay, the second factor is a squared minus ab plus b squared. So it's going to be x squared minus 4x plus 16. Now, take a look at that. Look at the pattern. It follows the pattern perfectly. You can always double check to see if you do this right by multiplying these two things back together. And if you do that, you should get x cubed plus 64. Okay, so that is the sum of two cubes. There's an example. The difference of two cubes is just about identical. The difference of two cubes, again, you got to identify what is being cubed. So the first factor, instead of being like this one where it's plus, it's actually going to be minus. So a minus b. The next factor is almost identical to this, except in the middle, instead of a minus, it's a plus. So it's still going to be a squared plus ab plus b squared. So there's the pattern. Basically, when it's a minus, you start with a minus, but the middle is a plus. All right, so let's do this one. This one is y quantity cubed minus 3 quantity cubed. So your a is like your y, and your b is like your 3. So you get y minus 3. Again, I just used the same sign in the first one. The second one is going to be identical to the one we did earlier, but it's going to be a plus in the middle. That's a difference in a sum of two cubes. Okay. They go to a couple different ones in the book. I don't know why, but they extend it out past what I just showed you. These are the basic ones. You definitely have to know how to do these. Your worksheet and your assignment and the test is going to have real basic ones on there, but you still need, it will have a little harder ones as well. So we need to know how to do the easy ones first. But then we go to the 1A and 1B here. So let's just go ahead and try these. When you look at 1A, you don't see perfect cubes. However, if I take out a greatest common factor of 5y, I end up with y cubed minus, what was that? 5 goes into 32. That would be 64 z cubed times. Now, this is a perfect or difference of two cubes. When you look at this, you've got 5y still. You have y being cubed minus 4z being cubed. Once you identify what's being cubed, you can set it up in using your pattern. So the 5y is still there. The first factor is just y minus 4z. The second factor is going to be y squared plus y times 4z, so 4yz plus 4z squared, which is 16z squared. And that's your factored form. Okay, this one, very similar. You take out a greatest common factor. It looks like I can take out a negative 2w. That leaves me with 27w cubed plus 125z cubed. Okay, so in this case, I've got negative 2w out front. What's being cubed in the first one is 3w. What's being cubed in the second one is 5z. So this is like your A, this is like your B. Again, I'm just going to put the negative 2w out front. I've got the first factor, which is going to be the 3w minus, or I'm sorry, it's a plus 5z. The second factor, you square 3w. So it's 9w squared minus 3w times 5z is 15wz. The last term is going to be 5z quantity squared, which is plus 25z squared. And there's your factored form. Okay, so that is the sum and difference of two cubes. Something we're going to look at and use quite often. And so you really need to know how to do this. Practice problems. Practice problems, check your answers. You can find problems online or whatever you need to do. Let me know if you need help. I'm going to try to keep you up to date on this and help you through it. But you need to let me know if you need help.